Okay, right. So the first video for today is just a recap of on integration. Okay, and Olivia again, I'm afraid it's gonna all have to be you. Okay, so I've got a curve, f of x. Okay, and when I ask you to find the derivative, okay, the derivative, let's write it down here. What is the derivative of it?
It's the gradient of the tangent.
Fantastic. It's a gradient at that specific point. The slope, the gradient. Okay. So write df to dx. We can write it like this. We can write it like that. What is the integral of f? The screen doesn't really come with that method. So f of x dx. What does that mean? Physically. Remember? No. So if the derivative is the gradient, if I integrate f of x from x equal 2 to, let's say, x equal 4, okay, that rings a bell? No? Yeah, it's a start one. That means what you do, you take this area, this domain, I guess you go from 2 to 4. Yeah, you've got these rectangle, and it's basically the area under the graph. Okay, so if this is the gradient of the graph in that specific spot, that's the area under the graph. Okay? Now so that's physically what it means, okay? But mathematicians really like to just know how to calculate it, okay? So if I have, let's say, let's go general. So let's say y equal ax to the power of n. Certain function, a polynomial. Okay? If I want to know what dy to dx is, what was the formula? So I've got some number times
n times a
x to
times
the power.
n minus 1.
Fantastic. Okay? Now the integral of y, and we all write these little dx's here. These dx's are what you meant are these little lots of rectangles, right? Because what I'm doing really, I'm adding lots of rectangles, summing them up. Okay? The difference is dx. If you really, this is a really quick recap. You know, if you have some time, it will be a good idea to go back to grade 11. It's all still there on my playlist. You can reach my playlist by going to Woodridge College Academic, and it's that first page. You can get to my playlist, or you can just write Kalish on YouTube.
Yeah, I just searched
it. You can go to grade 11, the playlist AP, and you'll find. I think it's worthwhile watching the first lesson on integration, just to kind of go, what is it about? How would I integrate this function? Remember, this is this y.
There's an n involved.
So let's think, often we call this the antiderivative.
So you're taking it back?
Yes.
Yeah.
You kind of do the opposite. So if here from n it went to n minus 1, here it's going to be x to n plus 1. It goes up 1.
Yeah.
Okay? But then the other thing is,
over.
because what you got to think is, whatever that is, if I differentiate it, I'm going to go back to that. So you got to build it up in your mind. What will it be?
Divided by n.
Divided by what? Because think, if you now, this thing you're going to differentiate it. So this n plus 1 will jump out to here, right? Like this n jumped to there. So I don't want n plus 1. I don't have n plus 1 here. So I need to divide by n plus 1. And then I need to still have one thing here. Okay? Right, so let's just have a look at this. An plus 1, just to check it. If I was to differentiate it, I'll actually give it a little bit more space. We'll see why in a second. If I differentiated it, I'm going to have x, the n plus 1 will go down 1, right? It will become n. The n plus 1 will jump to the other side, so it will be n plus 1 times a divided by n plus 1. That will cancel, and then I'll have back my original function, which I want. But I forgot something. So I've got this. This is constant. Plus a constant. Now why plus that constant?
Because if you found the derivative of that constant, it would be
always 0. A derivative of a constant, dc to dx, where c can be any number, is forever 0. So this is, we often call it, I don't know if I use that name, it's the constant of integration. And if I just ask you to calculate the antiderivative, as we will do now in a couple of cases, you just write plus c. But in some cases where you know a little bit more information, then you need to determine the constant of integration. And we will do an example like that. Okay, I'll just pause here. So that's the formula for the antiderivative. Really, that's the main thing you need to know. Okay, so armed with this formula for the antiderivative, we're going to calculate the derivatives of, or the antiderivative. We'll calculate the integral. Okay, it's called the indefinite integral, because indefinite integral we don't have from where to where. Okay, and when we calculate the indefinite integral, when we don't have these boundaries, we're always going to have a constant of integration, like a plus a c. So now when we have 2x cubed plus 5x minus 2, when I integrate that, what's the rule? When we have a sum of function, how can I do that? Would you integrate?
Or each one.
Each one, yeah, each one. I can say, okay, it's 2x cubed dx plus 5x dx. Or to write that dx all the time. Minus 2 dx. Okay? You just integrate each part. So incidentally, we have this rule. I'm just going to check, is this on its own? Okay, so we've got a rule here. If I've got two functions of x, a sum of function, and I'm integrating that sum of the function, I really can do, obviously that could be minus or plus minus, integrate one and plus minus the integral of the other one. No problem, okay? Alright, so 2x cubed, I'm just going to do it quick if you don't mind, Olivia. So 2x cubed is going to be x to the power of 4, and then I know, I can write down divided, what I can do is, the rule that I told you, I have to put the 4 below and the 2 above. That's if you want like an algorithm without thinking. You can just write it like this. Okay? That 4 goes down, and then you still have that 2. But you can just think about it sensibly. You know, what do I need to more? I'm going to, the 4 can come down here, and then it's going to become 2. So I know it's just half. Just a quick step if you want to do it. Plus, okay, now I should really write plus c. Okay, and maybe I'll call it c1. I'll just talk a little bit about that later, because each one of them has a little constant of integration. Plus, what is 5x? Well, the x become x squared. Now, here, I need to have that 2 here, so when the 2 comes out, we'll cancel that 2, and I'll have a 5x, so 5x squared over 2. And I can add its own constant of integration, c2 we'll call it. Plus, okay, what happens to the 2? Well, maybe I will ask you there. So it's not plus or it's minus. What's the integral of 2? When you have just like a number.
1, 0.
The derivative of 2 is 0. The derivative of each of a constant number is 0. But the integral will actually be 2x. Just not x. If it was 2x squared, 2x squared is the derivative. Yeah, 2x. Okay? Because 2x, if you do the derivative, what's the derivative of 2x? Just 2. So if I just had 2, the antiderivative is 2x. Okay? Alright. And I'll add its own c3. Now that was madness, wasn't it? Why do I have to add c1, c2, c3? These are just numbers. I didn't really need to do it. I could just get rid of all these ones and add a c at the end. That's what you should do. Okay? Because we don't know what they are anyway. Okay? Alright. The next one, are you happy with that? Okay. Next one is more difficult because now we have, okay, a square here, that's fine. But now we've got x squared at the bottom. Here we've got some roots. So remember, what I'll do is two things at the same time. I will do the integral of each one of them. First one was easy. How would I write that? It's going to be the integral of 3.
times
x to the power minus 2. I want them all to, the x to be up and give them some funky exponents. Okay? Dx. And then I still have a minus 4. Okay, what will be the exponent of x squared? Root
x to
cube.
the power minus 2 over 3.
Minus 2 over 3, you're right. Minus 2 over 3. Yeah? Yeah. Great. Okay, and then I'm doing the integral of each one of those. So x squared dx will be x cubed over 3. I'm not going to add a constant now. I'll do the constant at the end, plus c. Okay? Minus, okay, x minus power minus 2. Let's think about that. What will be the power when I integrate that? The minus 2 needs to, we always go minus 1. And then, because I have 3 here, it's actually going to be plus 3. Check this out. So minus jumps here and we'll turn the plus 3 to minus 3. Okay? Minus, or we'll write minus, it probably will be plus at the end. Okay, this is a little bit more difficult. What will be the power of, it was minus 2/3 plus 1. How much is that? You can use a calculator, it's a third. Okay, it's a third. It's a third. Minus 2/3 plus 1 is a third. And now, I want to have a 4 here. I want to have a minus 4. So, I'm going to keep the minus actually. I'm going to keep the minus.
Didn't you say 4 divided by 1 over 3?
Yes, 4 divided by 1 over 3, or, which is 12, yeah. So, it's minus 12. And let's check that. It's always good to check. So, now, the third time minus 12 will be minus 4. Okay, I think you got it. N plus C. Okay, so that's like mechanical integration without thinking too much. I'll pause here. Okay, just a quick correction here. That brackets, the brackets was here. The dx, if you have like a sum of function, the dx must be outside the brackets. Okay, so as the last example, I've chosen actually not the example that I had in the book, but one of the exercises, which I thought is quite difficult, more difficult than what they had as an example. And it's a classic physics question. So they tell you that they throw a ball. I'm standing on the balcony, 20 meters high, and I'm throwing a ball upward. It goes up and then it falls down. Okay? Now they tell me that h is the height. Okay, so h is the height at any given moment. So h is a function of time, is the height. Now they tell me that the change in the height, dh to dt, is 15 minus 10t. Okay, what is dh to dt? Okay, it's derivative of h. Now one of the things that I need to have, I don't have here. If I was teaching physics, I don't teach physics in high level, but when you do physics, you need to have a maths hat and a physics hat. And you start the problem with a physics hat, then you're going to put your maths hat, solve the problem in maths, and then put back the physics math and figure out what does it mean. So that's the maths hat. dh dt is the derivative of h. But what is h? What does it mean? It's the height. So it's keeping that physics hat. What is dh to dt? What is the derivative of the height? So height is another, it's a specific displacement. When you learn of displacement normally we work with x, so it's a horizontal displacement. Okay? And you can work with, now we're working y, we call it h, doesn't matter, it's a vertical displacement. So what's the derivative of the displacement? What is the derivative? It's the rate of change. The derivative is always rate, how fast it changes. The velocity. Okay? So that's your velocity. Vertical velocity. It's the speed. Well, it's not really speed, because speed is just the magnitude. Velocity can have plus and minus. When it's plus, it's going up, you record it, and when it's down. Okay, so dh/dt is in fact what you will call v, or the vertical velocity, vy maybe. Okay? Yeah, okay. So what they're asking us, they're actually asking us to show. They're basically asking us to find what the h of t is. They told us what it is, and they need to show it. But I'm not going to show you, we're going to figure it out. Okay? So how am I going to find h? I'll just pause here for a second, let you think about it. Okay, all right, great. So well done. So the question was, I've got the derivative of h. How do I find h? Well, because we are recapping integration, yes. Okay, dh to dt. Okay, I'll explain what this thing means. Actually, this is a really heavy thing. This thing is called the fundamental theorem of calculus. It tells you that if you've got a function and then you've got a derivative of that function, if you integrate the derivative, you get back that function. I think we did that. You reverse it, okay? So if I've got a function, okay, and I do the derivative, if I integrate,
You get back to the function.
I get back the function. Okay. Fundamental theorem of calculus. Very, very important. Okay? So another difference here is, which is probably very confusing, I don't have dx, I've got dt, which is a bit confusing, but you know, it's in the book, so I want you to get used to it. Often we have f of x, now we have h of t. It's just another variable because it makes sense to use t because t stands for time. Okay? Alright, so we're going to integrate it. Okay, so it's going to be 15 minus 10t dt. Okay? You see what's this? So we start with the physics hack. Okay, now we're putting the maths. This is just a normal maths problem, and in fact an easy one. But it's the problem in physics that you have to use the both hacks. Okay, so it's going to be 15 dt minus 10t dt. Okay, that should be pretty easy. 15 dt, maybe you can help me with this because that's with a number, but you struggled with it before. What will be, yeah?
15
But t, 15t, right? Minus 10, not 10, it will be t squared, right? Because the t becomes t squared. What number should I put in here so it will give us 10 eventually? Okay, so you understand why this should be t squared? It's 5, fantastic. So when I put a 5 here, the 2 times 5 will become minus 10. Plus c. Okay. So now, if I, okay, so what I've got h of t so far is minus 5t squared plus 15t plus c. So giving a certain value t, I can tell you where the ball is, how high it is. But can I tell you? Not really, I'm missing something.
The c.
I don't know what c is. So c, leave it as a c in last question was fine because we didn't have a physics.
20 meters for a reason.
Very good. You see, you are queen of numerical and of guessing, isn't it? Numerical says very, very good, very good. We didn't use that 20. Okay, so I know a certain point. Okay, which point do I know? For which? Starting point. Where t is equal?
To 0.
Correct. Good. Okay, so that's it. So h, when t is equal to 0, is 20. Okay, because that's what they told us in the beginning. Okay. So now I'm going to say, okay, I'm just going to substitute 0. So minus 5 times 0 squared is 0. 15 times 0 is 0. So c is 0. C is 20. Okay, I just substitute. Maybe I'm going to write it down for those who are not here. Just to make I'm just substituting t equals 0 inside here. So 0 squared plus 15 times 0 plus c. That obviously means that c is 20. And then I can update that equation. Now the red one is okay, I'll put it in red and voila. Okay? I'll just pause here for a second. Okay, so the last question, which is not so much to do with calculus, but we might as well do it because it's a good experience. They're asking us for which time the ball reaches at the end, the floor. Ball reaches floor. And we got to use this equation. What's the height at the floor?
0.
Okay.
No, it's to displacement. So yeah.
Displacement, not the distance.
Yeah,
the distance is not 0, but the displacement is
20 plus whatever that
so
section is there.
Here the displacement is 20.
Yeah.
here the displacement is 0. We call that 0. Right? You said in the beginning that when at t equals 0, h is equal 20. You told me. Yeah? So if here h is equal 20 and I'm moving down, this is the floor, 20 meters down, then h must be equal to 0. If this is h equal 20 and I'm moving 20 meters down, that must be 0, right? 20 meters below 20 is 0, okay? Now, we could have done something else. Hopefully I'm not going to confuse you. I could have said that here is 0, and then this would be minus 20, right?
That's how I saw it.
But you might have seen it, but you told me that here's the t is equal 0, but the h we said was 20, right? We wrote, I unfortunately erased it, but it was h of t equals 0, we said is equal to 20, and that's why we got c's. If we said h equals 0, then the c will be 0. We will have different c.
Okay.
Which actually is fine, but it depends what we define. We have the flexibility to define where is 0, and we decide that this is 0. Okay. So, no, not 20, 0. Okay. So now how am I going to solve that? How am I going to solve that? What t would give me h equals 0? What do I need to do?
Make the equation equal to 0.
Correct. So minus 5t squared plus 15t plus 20 equals 0. And that's a quadratic equation.
Yeah.
Shall we leave it there? Yeah. We divide by minus 5, make it, I think it should be do you know what actually? Let's just actually investigate it. So I'll divide by minus 5, t squared minus 3t plus 4. Minus 4 equals 0. Let's try and find that. It's going to be, what is that? T, two numbers that multiply to minus 4 and add up to minus 3 is minus 4 plus 1. T plus 1, right? Equals 0. Yeah, check me. Minus 40. Yeah? Okay, so we have two solutions. Okay. What are the two solutions? T, let's write them in red.
Look at a negative time.
That's it. So here we had our maths hat. Now we need to wear our physics hat. Okay. So t equal 4. That's good. I'm happy with that. T equal minus 1. No ways. Okay. We gotta reject that. Maths sometimes give us solutions that don't work in the real life. What probably that minus 1 means is that I could have maybe stood here and threw it there. Stood like I could. This function fits this, but it also fits if somebody was standing and throwing it there. Maybe I'm not sure. But you gotta be ready to reject solution using your physics set. That's it for the recap.